Welcome back to VMware Code at VMworld. Thank you for joining me for code session 2778, Talk Nerdy to Me, using Python to create VMs with vGPUs for AI workloads. I'm your presenter, Tony Foster. I work at Dell Technologies as a technical marketing engineer. I'm also a 10-year vExpert, a founding member of the NVIDIA vGPU Community Advisors, and I spend a lot of time doing non-standard things with GPUs and virtualization. So I'm real quickly going to switch screens here. And let's get into today's presentation. A few housekeeping notes. The full sets of slides with code will be available from my website, wondernerd.net. All of the code is also going to be up on my GitHub, which is github.com/wondernerd. And this particular session is VMworld 21. Please be sure to ask questions in the chat. I may not be able to answer them verbally during the session, but I will definitely reply back in the chat, and I will stay on as long as needed after the session is over to continue on the discussion. We've got a lot to cover today, so let's go ahead and get started. We have the standard disclaimer for all of the sessions, and you've probably seen this quite a bit, so I've shown it to you and you've been informed. That said, let's take a look at what we're going to be covering today. We're going to start with an overview of GPUs, some of the requirements around that to create the VMs. Then we'll get into the meat of the session, looking at the VMware mob and coding vGPUs into VMs. We'll then use all of that code and everything that we've created to build vGPUs into VMs in my home lab, at which point we'll start wrapping things up with resources and whatnot. So that's a quick overview of what's on the agenda for today. Let's spend a few moments talking about vGPUs and how they fit into virtualization. This is a slide that NVIDIA uses quite a bit that I like to borrow. On the left-hand side of the screen, you'll see the standard virtualization environment that we're all familiar with, the server, hypervisor, and apps or VMs. On the right-hand side, you can see a NVIDIA GPU has been added to the host, and this is passed up through the virtualization stack through all the rest of the components. In the hypervisor, a VIB is installed, which allows the GPU to be virtualized and shared among multiple VMs. This is known as a virtual GPU or vGPU, and I'll be using those terms quite a bit during today's session. In each VM that will have a vGPU, you need to load a vGPU driver to support the virtual GPU in the guest OS. And you can't just load any default GPU driver that you find. It needs to be one for vGPUs. If you don't, your VM breaks and you have to uninstall it and start all over again. With the driver loaded, you are then able to take advantage of the vGPU capabilities. For the longest time, these have always been assumed to be just for VDI. For quite a while now, though, you've actually been able to build VMs that can leverage vGPUs for more than just graphics. In fact, this week you've probably heard a lot about running AI workloads in your virtual environment. We're going to take these workloads a step further in this session. I'm going to demonstrate how to programmatically create VMs with vGPUs for AI workloads. We won't be installing any OSs or configuring the OS for a given workload. We just don't have time to do that with a 30-minute session. That and the workload admins that I've met get really picky about their OS build. We're just going to focus on building the virtual hardware programmatically. There are plenty of other places to get into how you install an OS programmatically. So let's move on here and let's talk about a few of the things that are required to be able to do the coding that we're going to be working on today. Obviously, you need a Vsphere environment with at least one GPU supported by Vsphere. In my lab, I'm using an NVIDIA P4. You can pick them up on eBay for about $400 a piece right now. You will also need to get an NVIDIA vGPU license. You can get an eval license on NVIDIA.com if you don't already have a licensed vGPU environment where you can do this coding. Next, there are the obvious things you need. Python, pyVmomi, pyVim. These are all minimum programming components you'll want installed on your programming system to build VMs. You'll also want a text editor or an IDE of your choosing. Now, I'm a very naughty programmer. I use just about anything, text editors, IDEs, whatever. Today I'm using Visual Studio because it's a bit easier for me to move around and show files off. So, let's talk about the Managed Object Browser. And this is another tool you want to have at the ready while developing and testing your code. And it's called the Mob. It's not short for Mafia, but you definitely don't want to forget about it either. It's VMware's Managed Object Browser for vSphere, and it provides you with a programmatic view of your virtual environment. You can get into it by going to your vCenter URL and adding /mob at the end of it. The slide I have up here is actually a cheat sheet I use for vGPUs and the mob. It basically reminds me where to go to find the different GPU attributes in vSphere. Now, let's hop into the lab and actually start coding some of this. We'll start out connecting to the vCenter in my lab, making sure everything connects programmatically. Then we'll get to the GPUs that the host has, along with the vGPU profiles that host supports. Then we'll snag all the VMs that have vGPUs in them. Once we know that, we'll add a vGPU to a VM. Then we'll actually remove the GPU, and we'll talk about why that is here in a bit. Once we've done all of that, we'll start tying all these things together to build a VM that has a vGPU configuration you want. Again, all of these slides and codes will be set up, will be up on wondernerd.net along with the deck and everything, as well as on the GitHub repository. So with that, I'm going to go ahead and switch over to my vSphere environment. So here you can see my vSphere environment over here on the left, all the virtual machines. And just for grins, here is the Managed Object Browser zoomed in so you can see my vsa.wondernerd.local/mob, and it takes me right into my environment. So coming back over here to our virtual machine, I'm going to log in. And here you'll see we have a bunch of different scripts. And the first one we're working with is this connect to VC. And this isn't all that exciting for most people. Most people know how to connect to the virtual center. But I want to walk through this real quick for those who don't. And we'll start out with line 14 and 15. I don't use certificates in my lab, so I'm using unsigned certificates here. And so I have to use the unverified context. So we're starting out there. You will want to change that if you are using verified scripts and or verified certificates in your environment. Then we create a connection to our vCenter. And here you can see all of the information to connect to it. And if it doesn't connect, we throw up a error message. And then for this particular script, I just print out the content from our connection. And throughout the rest of the programming examples I'm going to be doing here today, all of the code that we'll be talking about will fall between these new content blocks here. So this will get replaced with the next section that we do, and so forth and so on. So let's go ahead and run this real quick. And I'll expand this for you so that you can see what it's doing. And here it comes back with a ton of information about my vCenter. Yay, it means we've connected. And I know that's not super exciting, but it's a good place to start with all of this and makes troubleshooting a lot easier. That said, next we're going to go ahead and find out what GPUs we have in the environment. So I'm going to switch to that script. And like I said, the new script is all going to be inside those blocks. And this one, we create a host system view, so the create container view of the Vsphere environment. And we're going to go through all the hosts in the environment, which is what's happening here. This for loop loops through all of the virtual machines and prints out their name. And then it looks to see whether or not they actually have a config. If not, they're probably powered off or inaccessible. Then it looks for a shared pass-through GPU types, which tells us that it has GPUs in it. And lastly, it grabs the config graphics info, which is where the GPU card type is kept. And it prints out the device name for us. So let's go ahead and run this. And I'll expand my terminal window here just a bit. And so you can see 01, it has nothing. 07, it found a NVIDIA P4, and the rest of them, it didn't find any GPUs. So let's go ahead and shrink that back down. And that gives us our GPU count. Not all that exciting, but it's good to know that our GPUs are there. And it's also worth noting that these GPUs here, this config.device name, is going to be an array set. And that's because you can have multiple GPUs inside of a single host. So you may have multiple GPU entries as you're going through and looking at this. And that just helps you know what GPUs are available in your environment. Doesn't seem all that important, but it actually can help you when you're developing code to provide virtual machines to your end users. So let's switch this just a bit, and it's very, very similar code. In fact, all of it pretty well stays the same, except for line 44 here, where we use config.sharedpassthrough GPU types. So that's going in and getting the profiles available for a given card. And all of this is found through the mob. So we find this whole path, the .config.graphics info and config.sharedpassthrough types inside of the mob. And so when we run this, what it's going to provide is what vGPU profiles are available on a given host. So again, it's going to go through all of our hosts, and we're going to see that ESXi 07 is the one that has all of the profiles. And again, this may not sound like it's a big deal, but it's actually really helpful. We can use this to programmatically select which ones we want to use, like this P4 8C profile or P4 8Q profile if we want, or any of the other ones. We can put that in a drop-down list or some other system to provide the choice of, hey, what GPU do you need? So we can incorporate this set of scripting into our vSphere environment and programmatic or programming. So that's how that script works. It's pretty much identical to the previous script. Now, let's find out what VMs in my environment I have that have GPUs in them. And just to give you a sneak peek, here you can see about 6 of them. And the only one that has a GPU in it is that VMworld 2021. The rest of them are underneath these machines that are in maintenance mode and everything. So we're going to see how many I have. And the way this is done is a little bit different. And in this particular script, just for a change, I actually don't use a view. I navigate the folder structure of our vCenter. So you can see here, I'm going down the host content through the root folder and then into the data center and looking for VMs that way. So that's what I'm doing here instead of creating a view for virtual machines. In the next scripts, you'll actually see me do it per virtual machine. So this then goes through each virtual machine underneath the VMs folder and looks for virtual machines. Each virtual machine, it checks to see what the hardware device is. And if it has a virtual PCI pass-through card, which is what that virtual PCI pass-through is, and it has a vGPU backing, it'll then sit there and print out information about the virtual machine. And this is really important when you're working with these to be able to find that. And if it doesn't have both the pass-through and the vGPU backing, then it doesn't actually have a vGPU in it. And you need to test for both of them, because you can have multiple different types of virtual PCI pass-through devices. And you may not have a vGPU backing on it. So we're going to go ahead and run this script, and it's going to tell me all the virtual machines in my environment that have a vGPU. So this runs, and it's going to go through everything, and we'll get all of our different virtual machines. And you can see there's quite a few in here. The one we're going to be paying attention to during our session today is this VMworld 21. And notice that here we have compute 0 and holding VM02 on either side of it. So VMworld 21 only has one GPU in it for right now. And it's at PCI device 0. And that's important because in our next script, we're actually going to have some fun, and we're going to modify that virtual machine. And the reason we're modifying the virtual machine is because we're going to give it another GPU and talk about some of the caveats with multiple GPUs in a virtual machine. So we're going to click here and go to this script. And you may be thinking to yourself, but wait, I thought virtual machines can only have a single vGPU. In 7.0, that changed. That actually changed where you can have up to 4 vGPUs in a single virtual machine. There are still some caveats with that, though. Your virtual machine has to have the same type of vGPU in it to have multiples. So I can't mix and match different vGPU profiles. So I can't have a P4 4Q and a P4 2Q profile in my virtual machine. I'm completely capable of adding those, but that VM will not power up when I start it or when I try and power it on. It just won't run. It'll come back and throw some error messages at you. So to power it on, you need to have the same type. Those also need to be the same vGPU, or be the largest vGPU available on a given GPU. So for example, an 8Q or an 8C would be the largest profile available, and it's going to consume the entire GPU there. So essentially you're giving it an entire GPU plus another entire GPU. And you might be going, well, why don't I just pass through the GPUs directly to it? And the simple answer is you get a lot more flexibility doing it this way with vGPUs, because you can power down that virtual machine and those GPUs can be used elsewhere. So you're not tying them to a single virtual machine. It also means that you can archive machines and not have to break connections and stuff. So you can preserve your virtual environment. So the way this script works is we're going to build a view of virtual machines. So you see that here on line 36 and 37. And we go through and we find our VMworld 2021 virtual machine. And it's going to print that out and let us know that it found it. And it's going to create a reference for us that we're going to assign to the VM variable. If the VM variable is not blanked, we're going to create a configSpec. And so you can see the process to create a configSpec here, and the operation is an add. We'll go through, we'll put all of the information in for it, tell it what type of GPU we want to add, that it's a new PCI device, and that we're using a grid P4 4Q profile on that. And so we can run this, and I'll expand this real quick. And you can see that it found it and it added it. And if I come over here to my environment and we do edit settings on the VM, you'll see it now has 2 PCI devices in there. And if I expand my recent task just a little bit, you'll see that it did do a reconfigure virtual machine as well. So that is adding a virtual GPU to an existing VM. And if I were to try to power up that virtual machine, it would not work. So last thing, and it may seem like we haven't actually done anything that moves us towards building virtual machines programmatically, but you'll see exactly how all this ties in. We're going to do some cleanup and remove that GPU. That way I could actually power up that machine if I needed to. So again, this is almost exactly identical code. We're looking for VMworld 2021. And this time, once we find it, we're going to go in and we're going to find out what instance has the vGPU and the virtual pass-through information and everything. And we put that in a vGPU object. So right there is where we do it on line 49. We also let them know that we found it. And then we create a new config spec. And this time it's a remove config spec. We pass it the object we want to remove, which is our GPU that we found up here on lines 45 to 50. And we remove it. And this is fairly straightforward, so we'll play this, and if you watch down here, you'll see it reconfigure the virtual machine again. And you'll see that it has 2 vGPUs in it. And so if I come back over here and edit settings on this, you'll see that we only have 1 vGPU. And you'll also want to know that the way this script is architected, it's going to remove the last GPU that was added, or vGPU that was added from the environment. It's not going to remove a specific one. So if you wanted to remove PCI 0 instead of PCI 1, you'd need to modify how the script functions in finding vGPUs on a VM. Now let's tie all this together and make this actually a practical application. We're going to create a virtual machine out of all of this. And there is a pyVmomi pyVmomi community code set that you can get on the VMware code site. I also have links that will be in the slides, and we'll talk about that in a second, that walks you through creating a virtual machine. Only it doesn't have anything for GPUs. It has instructions for anything and everything else that you may want to add to it. So you can see here we're creating a config spec in this, and I just pulled this one straight down off of the pyVmomi community page on GitHub, and has memory, has the guest ID, name, CPUs, all of those wonderful bits of information. It didn't have GPUs. And if you think back to the add GPU script, we're just going to add this right into the config. So here we're defining a add part to the config spec in here, and we copied everything right on over from our vGPU instance. And poof, we get a vGPU that's added into our virtual machine. So it's real straightforward here. And if I hop over to, oh, went too far. Hop over here to my terminal, I actually have a script I built that has all of the different bits and pieces to add the virtual machine, because it actually takes a bunch of arguments. And so you'll see here I have VMworld new VM. And we can change that to whatever you'd like, but there it is. And it's that simple. Once you have all those pieces, it really snaps together quite quickly. So with that, let's go ahead and hop back over to the slides and wrap things up. So as I said, all of this code and everything is in the slide deck. You'll have access to it. And where do we go next? Take a look at Alistair's blog on building a virtual machine with pyVmomi. It's all based on this, and as I said, the pyVmomi community samples is where I got that last chunk of code, and all I did was add the config spec from the previous sample. Then we install an OS, we install our packages, we install the appropriate NVIDIA vGPU driver, and then install AI ML or DL package. Or if you want to do testing, you may want to consider installing the NVIDIA container toolkit, and the link's right there. You'll be able to get all the details and everything on how to do that and how to test that your GPU, or in this case vGPU, is working. Again, you can find all of this on GitHub, so please take advantage of that. These are some of the references that I used in building my knowledge on this. I highly recommend taking a look at the VMware VHPC toolkit out on GitHub. There's so much more that you can do with AI and ML machines, and they cover it really, really well in that GitHub. I'll be here till everybody else clears out and questions stop coming in. You can reach out to me on Twitter, wonder_nerd, or on LinkedIn if you'd like. These are some sessions you really don't want to miss. Even though most of them have already happened, go back and watch them. I highly recommend it. There are a bunch of great sessions, and a lot of them relate to this. So be sure to go back and catch these if you'd like. Last thing I'd like to say is please be sure to take the survey for this session. All of us really appreciate the feedback and everything on how you think the session went and what we can do to improve. So please take a moment to fill out that survey. And lastly, thank you for joining us this year at VMworld and at VMware Code at VMworld. We hope you've had a great experience this year, and we'll see you soon.